This session, we have Mona Obedoza is going to present to you. Now, Mona is a high schooler, tech enthusiast, and aspiring AI engineer, as well as a student ambassador for the Women in AI Philippines, and a co-leader of the Girls Can Code Club in her school. Wow. She has participated and placed in numerous local and global tech competitions and also hosts coding workshops and hackathons for students to further her mission of helping kids discover many possibilities of how technology and AI can help positively shape our world. In her free time, she enjoys watching anime, reading manga and fantasy novels, and baking cookies. You can learn more about her at Sunshine's Funny Software.tech. You can find that in the PyLadies conference website. Now, mental health concerns are a critical issue. 14% of adolescents suffers from disorders such as depression. Sadly, these often go unnoticed and making suicide the second leading cause of teenage death. Now, Mona is going to share with you a project that's very interesting. It's called Project Teddy, text-based early distress detector for youth. Mona, over to you.
Hello everyone, it's super great to be here. Are you all able to see my screen? Would you be able to give me some response in chat if you're able to see the slides? Yep, perfect. All right, I'll go ahead and start presenting. So again, thank you so much everyone for coming here today. Just a little trigger warning that there are going to be some mentions of suicide because of this topic. But with that out of the way, hello. As introduced earlier, my name is Mona. I'm a 10th grader and tech enthusiast from the Philippines. I've always been passionate about coding and artificial intelligence, and Python is actually what got me into this. It was my first programming language, and is still my favorite to use whenever I join hackathons and coding competitions. So I'm happy to be here at PyLadies Con today. Today I'm going to talk about how I was able to rapid prototype a text-based early distress detector for youth with Google Colab and the Python library Streamlit. It all started with the realization that 1 in 7 adolescents suffer from mental health concerns, and many of these go undetected and untreated. This makes suicide the second leading cause of teenage death. So this got me thinking, what if we could use artificial intelligence for early intervention and support? If it's alright, I'd like you all to answer me in text chat. Where do you think kids spend most of their day? Again, you can feel free to answer me in text chat. Where do kids spend most of their day, especially on weekdays? Exactly, they spend most of their day at school. And what is the most common type of homework that can reflect one's thoughts? Exactly, essays. So going back to presenting mode, there we go. Right, so the vision of Teddy is that teachers will be able to use it to easily upload student essays, and with a single click of a button, let AI take over and flag mental health concerns, which can now be sent to the guidance counselor for further analysis and support. To show you how this works, I'm going to show you the app that my team and I created over here at teddytechnovation.streamlit.app if any of you want to try it out for yourselves. So as you can see, this is the Teddy website, and over here is where you can enter an essay written by a student. So if I enter this essay about music over here, what it's going to do is that it's going to go through each sentence one by one and use artificial intelligence to determine whether there might be any cause or concern based on the language patterns. So as you can see, it divides it into 4 categories: concerning words, potential struggles, depressive thoughts, and self-destructive thoughts. Concerning words is just if it finds any overtly concerning words, such as perhaps empty or despair or violence or something like that the person might have included in their essay. It's not really indicative of any cause for concern in itself, but it might be worth looking into. And then potential struggles is where artificial intelligence is actually used. It's a highly sensitive test, so that's why it's just used for potential struggles or looking for any problems that the student might be facing in their day-to-day lives. Depressive thoughts is a little, well, less sensitive, sorry, and a little more serious, and it determines whether the language patterns used in the essay align with the language patterns generally used by people who have already been diagnosed with depression. And finally, self-destructive thoughts basically determines if the student might already be at risk for self-destructive or suicidal thoughts. So as you can see, you can scroll down and see all of the sentences caught that align with the above categories. Now, creating Teddy, of course, wasn't easy, and it took a lot of trial and error. But with the help of tools such as Colab, GitHub, Kaggle, Streamlit, and Python, I was able to put a sleek prototype together in less than a month. I mainly did this in 3 steps. The first one, of course, is data gathering and cleanup. For this, I just used Kaggle to find data relevant to my research and Excel to clean out weird characters. The second step was training an AI model using Google Colab, and the third step was deploying to the web using Streamlit and GitHub. So to go into more detail about how I trained my AI model using Google Colab, Python made it easy to test different models with just a few lines of code, and Colab made it easy to test a few blocks of code at a time to see which particular algorithms or methods work best. So this is my Google Colab notebook. Just checking, is everybody able to see it? Wonderful. All right, moving on then. So of course, the first thing I had to do was load the CSV file. This is where all of the training data is. So I got most of this data from Kaggle and other online sources. Of course, all of it is open source. And then basically what this is like social media posts written by certain people, and then it has one if the person who wrote the social media post is confirmed to have experienced depression, and zero, I think you will see some entries with zero all the way down there. There are like 200,000 entries here. Zero if the person who wrote the social media post doesn't really have any confirmed mental health concern. So we use this to train our model. And I realized that directly uploading the CSV file over here in the runtime files dialog in Google Colab made it disappear after runtime. That meant every time I wanted to code, I would have to wait like 1 or 2 hours just for the file to upload. And then after that, I would have to repeat the whole process again when I start coding again. So what I did to get around this was I connected to Google Drive to get permanent access to my file. So I had to import all of these different libraries. And then after that, of course, the first thing it did would be to authenticate the user and authenticate my Google credentials. After that, what I had to do was put in the file ID from the file that I uploaded to Google Drive. So as you can see, I uploaded my dataset over here in Google Drive, and I can simply click share, click copy link, and then I can put it over here. And this part over here, this part between the slashes, this is the file ID. So what I did was I copied it and I pasted it over here in my Google Colab. After that, I called drive.createFile using the file ID, and that allowed me to download the file as clean as data.csv. Then moving down here, these are just all of the different libraries I use. As you can see, I tried and experimented with a whole lot of things. I think a lot of these I didn't actually end up using in the long run, but I'll just go over them. Some of the ones I did end up using quickly. So of course, I ended up using NumPy and also Pandas, and I also used NLTK, which is very helpful when tokenizing and working with like the sentences that you're actually going to put in the AI model. And then, of course, I use Pandas to set up a data frame in my CSV file using pad.readCSV, and then I just enter the details for the file. And then after that, this is the exciting part already, I transformed it using sklearn. I found that Python's sklearn library has a lot of different AI algorithms and allows you to train an AI model in just a few short lines. So I just used train test split to get the data all set up. And as you can see, I just used around 25% of the data for testing and 75% of it for training. And then afterwards, I just set up the vectorizer in order to make it fit the model. And then after that, of course, the next part is training and downloading the models. So later on, in order to work with Streamlit, I would later have to do that on my local computer instead of just doing it on Google Colab. So in order to get everything set up for this, I had to use droplib to download all of the files I used in Google Colab, all of the models I trained as PKL or SAV files. The vectorizer, I found it was best to download it as a PKL file, and over here I also downloaded the models as SAV files. So we tried a whole bunch of different algorithms. Some of the ones we tried are naive Bayes, decision tree, SVC, linear SVC, random forest, and k-nearest neighbors. However, we found that the algorithms that yielded the best result were logistic regression and XGBoost. So as you can see, logistic regression yielded an accuracy of around 93%, and XGBoost yielded an accuracy of around 91%. So I just had to import these models, and with just a few lines of code, I was able to fit it and then print the accuracy score. Alright, and that's about it for the Google Colab part. Before I go on to the part about deploying it on the web, I just want to quickly check if anybody has any questions or anything you'd like me to go over in the Google Colab. Alright, if everyone's all good for now, then let's continue. Wonderful. So let me know in the chat, have you ever tried to create a UI in Python and found it very clunky and time-consuming? For example, recently with my teammates, we tried to create some kind of time management tool, and we tried to use Detector, which is a Python library for creating some user interface stuff, but we found that it was quite difficult to work with, and also, and generally it would just be a kind of like plain white background unless you customize it further. But as you can see, with Streamlit, we managed to create this sleek user interface that was accessible via the web, which means the user doesn't even have to download everything, and it already came up with a sleek user interface all set up and ready for you to work with. So going on to the GitHub to show you how exactly we set up the Streamlit, well actually first you might be wondering where all of these files that we got, logisticmodel.sav, xgbmodel.sav, and also our vectorizer pickle file actually went. And that went over here to this file that we named prediction.py just to make it easier to do all of the AI stuff in the actual program. So here, as you can see, we just had to import joblib again. And then here, when we use joblib.dump, when actually putting the information in the file, what we used here was joblib.load in order to extract the information from the file. And then from there, we were able to actually use the AI models to make predictions. So as you can see, we just defined some simple functions to go over everything in the SAV file and then run the data through it and then return the prediction. So we did that for XGB and for logistic regression. And then afterwards, all we had to do in app.py was to import the prediction.py thing we made, just like you would any regular Python library, and import all of the functions that we came up with that could later be called in the actual code. Now, as for the front-end part that I was talking about, in order to pull this off, we did import Streamlit as st. And if you scroll down, it's kind of like doing HTML. You have title, which makes really big text. You have various subheaders. You have captions, which makes really small text, and you have regular text as well. So as you can see, st.title, I put welcome to Teddy. And as you can see, that's what appears over here, welcome to Teddy. And I even managed to make it violet by putting this code over here, violet, and then putting Teddy, the text that's supposed to change color, inside brackets. So that's a common thing in Streamlit. You notice that if you have to format something, you generally have to put it in brackets. And then, of course, we also did st.subheader, that thing over here that says text-based early distress detector for youth, and st.caption to make this small text at the bottom. And then with Streamlit, you can also make containers in order to make everything look a little more sleek and organized. So in order to do that, we did in column 1, column 2, column 3, and column 4, and initialize these as st.columns, well, 4 columns. And then with Streamlit, you have to use the syntax with in order to make something appear under a certain container. So with column 1, and then after that, you can put all the different things that you're putting under column 1. Here it's the concerning word est, and as you can see, all of that text appears under here in the first column. And we basically just did the same thing with column 2, column 3, and column 4. And then I made another container at the side over here, st.sidebar. So I did with st.sidebar, and then I can also put another title here. As you can see, the same things for title, subheader, etc. work even if you're just making it put inside a container. And then I just put a text input. So over here, this thing over here where I could enter some text. And I can also use st.button in order to submit the text. So the first parameter you enter here is just submit text. That's the label that's going to appear over here on top of the button. And then on click equals, and then after that you can put the function that's going to be called when the button is clicked. So just going up a little bit, This is the function that's called when you click the button. First, it just double checks that the essay is not just some blank text, because otherwise, the moment you turn on the website, it's immediately going to assume that the button was clicked and run this function, even though there isn't any text there yet. And we don't want that to happen. So I made this code only run if the essay text box actually has something inside it. And then afterwards, I sentence tokenize the essay. That means I go through it sentence by sentence and run each individual sentence in the AI model. We found out that this is the best solution as opposed to like word tokenization or something like that, because it turns out that language patterns indicative of mental health concerns seem to be present on the sentence level instead of just in individual words. After that, After that, I just managed to make all of the different red flags caught appear in the different columns, as you can see here. And to do that, I used, where is it? st.container. st.expander. So it makes this little expandable container thingy. And so that means that you can just open it and close it depending on what you want to see. And I don't know, I just thought it looked kind of cool. Scrolling down, another thing that you can do is st.fileuploader. So as you can see, there's also a method for uploading a PDF file. You can just click this and it will browse files, and then you can just upload a PDF with an essay inside and it will analyze that. And you can also specify the particular file type that you want to look through. Like, of course, I don't want anyone uploading images here because I wouldn't really know what to do with that. So I put type equals PDF, so it can only be restricted to PDF files. And then after that, I put st.button to submit the file that was uploaded. And at the bottom, you can also notice that there are a few little hyperlinks here. One says learn more about Teddy and it leads to our website. The other one leads to a feedback form. So I did this by putting the hyperlink text in brackets and then putting the actual URL in parentheses. And so that makes a little hyperlink there that users can click on to lead them to other websites. And then, of course, so that's how you make the actual code for the Streamlit website. But the thing is that if you run this locally on your local computer, it isn't going to create something that's publicly accessible yet. It's just going to create something using local hosts that you can only access yourself. So in order to make it publicly accessible with a neat little link like the one they made over here, we use Streamlit Community Cloud. So what you can do here is go to streamlit.io/cloud and click Get Started. And then afterwards, it leads you to the site called share.streamlit.io. And so from here, you can just kind of like link your GitHub and then click New App. And you can just enter the link to your GitHub repository, enter the branch that you want, and enter the file where all of the Streamlit code is, and enter the URL that you want for your app. And then you click Deploy, and you end up with this nice little website over here. So another requirement I forgot to go over for Streamlit Community Cloud is that, let's go back over here. You need to create something called requirements.txt, because generally, if you're going to make like a complicated app, you're going to need to import some Python libraries, and so you need to just basically tell it that it needs to install all of these things in order for your program to work. So you basically just have to find all of the Python libraries that you use. For me, I use NumPy, SciPy, Pandas, etc. And then you can just go to your command line, find a particular version of that library, and then just specify it over here in this requirements.txt file. And then from there, Streamlit will already know that it has to download all of these particular libraries with these particular versions, and that should make your app work. Alright, and that's about it for how to deploy to the web using Streamlit. And that's about it for the entire talk, actually. I hope I was able to demonstrate how Python and Streamlit can help you rapid prototype a proof of concept for your AI projects. So thank you so much, everyone, for coming here today. I hope you had fun learning all about Python and Streamlit. And yes, putting the floor now for any questions.
Hi, thank you, Mona, for such an interesting project. And we do have a lot of comments coming from the audience here. Everybody loved your presentations. Let me see if there's any questions over here. Anybody, if you have questions, put it here. Before I don't see any questions so far. And for the quick one, I do have questions for you. So now you have the Teddy project here. So what's the next project, or what is the next phase you see for yourself or for this project?
Well, for Teddy, actually, part of the reason I wanted to present it here today was in case anybody would like to pick it up and try to and try to implement it. Like if you're affiliated with any school that might find this useful for your students, then you can just then yeah, you can just reach out to me and let me know if you would like to try implementing it so that we can actually so that Teddy can actually start making a difference in the world. And then as for me, I'm just continuing to learn more about coding. Recently, I'm joining a work experience program with AWS and learning more about coding and artificial intelligence so that I can continue to apply my skills towards creating projects that can make a difference. And I'm also thinking about some new projects down the line, but for now, those are a secret, and hopefully you'll end up seeing me again at the next PyLadies Con talking about them.
Definitely, we love to. So everybody, you hear her. If you know any school who want to implement this kind of project, contact her. Now, there's questions coming from Michaela. Michaela is also coming from Philippines. She asked, where do you get all your passions for all this project?
That's an interesting question. I think I started coding when I was very young, actually, when I was around like 5 years old, and I just started with block-based coding. And at first, it was just a hobby. It was just a thing I did when I didn't want to interact with other people at parties, so I would just sit in the corner and program by myself. But then eventually it became a passion for eventually I started to realize that technology can make a real difference in the world, and I came to this realization when I started joining tech competitions. I started joining like Lego robotics competitions and that kind of thing. And in these kinds of projects and these kinds of competitions, you have to create projects that are meant to solve a particular problem in your community. And so that encouraged me to think more about how I can use technology to solve problems in the world around me. And that kind of made me more, passionate about looking into all of the potential that technology has for that purpose.
That's cool. We are running out of time, but there's a few more questions. I think that you'll be able to quickly answer them. This one coming from Amerita. Any alternative to pandas that you can think of?
That's an interesting question. I'm actually not sure. I'm actually not sure about that. I mostly use pandas all the time just because it's really great for like analyzing data frames, and that's usually what I learn about when I ask about data science or when I attend the course about data science. So I think pandas is really just the most highly recommended one. But in case I ever find any, I'll just let you know.
Thank you. Now, this coming from Michaela again. How can the Python community support you and your community?
Actually, an interesting thing is that I'm holding a hackathon recently as part of my organization, the Purposeful Mochi, which you can find on Facebook. And so with that hackathon, I'm hoping to inspire other girls, I'm hoping to inspire other girls like myself to explore how technology can make a difference and explore how they might end up in a career in technology. So you can actually learn more about that by going to facebook.com slash the or well I'm not actually sure what the link is, but just enter the Purposeful Mochi. If you search that up online, you can find our Facebook page, and I really advocate teaching kids how to code at an early age, especially girls. So it would be really great if you could just share that around and share my page around and share any events that you might find interesting with your kids or with your nieces or with your students or anyone who might find it interesting.
Thank you, Mona. You are so inspiring, and all the audience definitely agree with me. So thank you very much, and hope to see you in the next conference, whichever it is. All right, thank you, everybody,
Thank you so
and
much.
I'll see you. Yep, I'll see you in next session. Bye.
Thank you, everyone. Bye.